So we want to solve this equation here in the same way as we do when we're solving quadratics. Bring everything over to one side, so that we just have 0 on the right hand side. Now let f of z be equal to 3z to the 4 minus 3z cubed minus 14z squared, take away 11z, take away 3. Now this is a quartic, so to get down to a quadratic, ideally I'd like to find 2 of my factors by using the factor theorem. So let's try f of 1. So that's 3 take away 3, take away 14, take away 11, take away 3, and that clearly is not 0. What about f of negative 1? So that's going to give me 3, add 3, take away 14, add 11, take away 3. So with the positives, that's 17, and then we've got to take away 17, so that is equal to 0. So z plus 1 is a factor. We don't need to try 2 because it's not a factor of 3, so we're going to try 3 next. So we'll go for f of 3. I'll probably use the calculator for this. So that's going to be 3 multiplied by 3 to the power 4, take away 3 multiplied by 3 to the power 3, take away 14 times 9, take away 11 times 3, take away 3. And that does give me 0. So that tells me that z minus 3 is a factor. So if we multiply those together, z plus 1, z minus 3, that gives me z squared plus z, take away 3z, so that's take away 2z, take away 3 is a factor. So we can say that 3z to the 4 minus 3z cubed, take away 14z squared, take away 11z, take away 3, is equal to z squared minus 2z, take away 3, and then we need another quadratic. To get 3z to the 4, I need 3z squared. With a negative 3 here and negative 3 here, I need a plus 1, and we'll need an az. So let's look at the z cubed term. What gives me that over here? Well, if we do this one times this one, that will give me a z cubed. And if I do this one times this one, that will give me a z cubed. So those are the only ones that give me a z cubed. So I've got negative 3z cubed is equal to negative 6z cubed plus az cubed. So 3z cubed is equal to az cubed, and that means that a is equal to 3. So what we have is z plus 1, z minus 3, which is this, and then 3z squared plus 3z plus 1 is equal to 0. So two of our solutions are obvious, and we get the other one from 3z squared plus 3z plus 1 is equal to 0. So z is going to be negative 3 plus or minus the square root of 9 take away 4 times 3 times 1 all over 6. So that's negative 3 plus or minus the square root of negative 3 over 6, which is negative 3 plus or minus I root 3 over 6, which we could write as negative a half plus or minus I root 3 over 6. So our solutions are negative 1, 3, negative a half plus I root 3 over 6, and negative a half take away I root 3 over 6. And once again, note that we started off with real coefficients, and where we have a complex root, we also have its conjugate.